For example, for merge sort A is equals to 2. Two subproblems are created. B is equals to 2. Each subproblem is half the size. F of n is equals to big O of n, which is the cost to merge two sorted arrays. This leads to recurrence T of n is equals to 2 into T of n by 2 plus big O of n. We solve this to get T of n is equals to big O of n log n. Hello all, welcome back to Being Passionate Learner. I hope you all are doing great. This is fourth lecture of Design and Analysis of Algorithms. In this video, we will dive into fascinating world of divide and conquer, which is a powerful algorithm design paradigm. But before we get started, if you are new here or haven't subscribed yet, hit that subscribe button and turn on the bell notification so you will never miss any of my upcoming videos. I have planned the amazing contents for you. Now let's discuss how divide and conquer works and why it's so important in computer science. So we will begin with introduction to divide and conquer. Then we will discuss steps in divide and conquer, general recurrence relation, classic examples, some applications, and lastly we will discuss advantages of divide and conquer and challenges in divide and conquer paradigm. Introduction. Now let's start by understanding what divide and conquer is. It's an approach where we break a problem into smaller and more manageable subproblems. We solve these subproblems independently and then combine their results to solve the original problem. This paradigm is crucial because it helps simplify complex problems and often leads to more efficient solutions. Let's now discuss what are the steps in divide and conquer. Divide and conquer typically involves three steps: divide, conquer, and combine. First, we break down the problem into smaller subproblems. Next, we solve these subproblems, often using recursion. And finally, we merge the results from the subproblems to form the solution to the original problem. Now let's discuss recurrence relation, which are used to analyze the time complexity of divide and conquer algorithms. A recurrence relation expresses the overall time complexity in terms of smaller subproblems. The general form is T of n is equals to A into T of n divided by B plus f of n, where A is the number of subproblems, n by B is the size of each subproblem, and f of n is the cost of dividing and combining. For example, for merge sort A is equals to 2. Two subproblems are created. B is equals to 2. Each subproblem is half the size. F of n is equals to big O of n, which is the cost to merge two sorted arrays. This leads to recurrence T of n is equals to 2 into T of n by 2 plus big O of n. We solve this to get T of n is equals to big O of n log n. Let's now discuss classic examples. Two classic examples of divide and conquer algorithms are merge sort and quick sort. In merge sort, we divide the array into two halves, conquer by sorting each half recursively, combine by merging the two sorted halves. This gives it a time complexity of big O of n into log n. In quick sort, we choose a pivot and partition the array, conquer by recursively sorting the partitions, combine trivially since merging isn't required. Its average time complexity is big O of n log n, though the worst case is big O of n square. Divide and conquer is also used in other algorithms. For instance, binary search. In binary search, the array is repeatedly divided in half until the target is found with time complexity of big O of log n. Second is maximum subarray problem. It finds the subarray with the largest sum in big O of n log n. Third algorithm is Strassen's algorithm for matrix multiplication. This algorithm reduces the time complexity compared to the classical approach. Let's now discuss advantages of divide and conquer. Divide and conquer has several advantages. It simplifies problem solving by breaking problems into smaller parts. It reduces the time complexity in many cases. Its modular approach also makes it easier to implement and debug. Now let's discuss challenges of divide and conquer. The overhead of recursive calls can impact the performance. The space complexity may increase due to the recursive stack. Additionally, not all problems fit this paradigm, such as those with overlapping subproblems. With this, we reach to end of this video. If you found this video helpful, don't forget to like, subscribe and hit the bell for more algorithm insights. Thank you for watching and I will see you in my next video. Till then, being passionate learner, keep learning. Thank you.